Oh, I guess we're going. So here we are with another video, second to last one. We're getting towards the end of this unit. Today's topic, as you can clearly read, is solving inequalities. So we're going to get started with that any second now. So we've been solving equations, and now we're just going to solve inequalities, and they work just like equations, except for instead of an equal sign here, you see that we've got the greater than sign. So it doesn't make a whole lot of difference in terms of the answer. It just is the only thing it impacts is doesn't really impact much other than just the form of the answer. So as I go through here, we're just going to solve this like it's an equation. So if I were trying to get x by itself, we're solving for x, so we undo things. We subtract 5 from both sides like we would normally. And so we're left with 3x, and we just keep the greater than sign. And 8 minus 5 is 3. Okay? And then we're going to divide by 3, divide by 3, and x is greater than 1. That's about all. Okay. Sometimes with these we show a visual of what we're looking at, and so typically we make a number line to see what that actually means, that x is greater than 1. So I usually have you put in on the number line 0, so we have a relative frame of reference. We put in where 1 is, and where's greater than 1? Out here. Okay. I made just a circle here to show 1 as my boundary, but I didn't fill it in or do anything like that because the answer can't be 1. It's got to be bigger than 1. So anything out here is part of the solution to the equation. That's what this is talking about. That's where x is greater than 1 is all this over here. But 1's not actually part of the answer. So it's just like solving an equation, except for it's an inequality. Okay. So if we go through this one, and the idea would be, of course, if you feel like you want to do this by yourself, pause the video and then do it, and then come back and follow up with me. So you can do that at any moment that you like, but we'll continue here. We add 7 to both sides, right? Add 7. And so we have 2x is less than or equal to 25, right? And then we divide by 2, divide by 2, x is less than or equal to 10. And so we make our number line. Again, frame of reference 0, 10, and we're going to be going less than, okay, so we're going to be pointing in that direction, okay? And this time it's or equals to, so actually 10 could be part of the answer, so what we tend to do, it's more difficult to do with this thing, is we fill in the circle. So that means 10 can be part of the answer. So anything less than 10, and continues down, I didn't go down past the 0, but down in there, anything less than 10, if we plugged it into the answer, we would have the solutions. X is less than 10, that's the answer, less than or equal to 10, I'm sorry, and that's the picture of x is less than or equal to 10. So really not that much different. If you noticed in this unit, we keep kind of circling back on the same things we've been doing, but just in a slightly different way. Okay, so here's one that's just the one major difference between solving an equation and solving an inequality. So far, I've done nothing spectacular here, right? Now here's the thing. I'm going to divide by negative 5. I'm going to divide by negative 5. Okay? X on this side, I get negative 3. Whenever we multiply or divide by a negative number within an inequality, we need to change the direction of the inequality sign. So where before it was less than, it now becomes x is greater than negative 3. Okay? So I'm going to write that here because it's important. When you multiply or divide by a negative number, the right number, I guess, negative number, change the direction of the inequality. That's what that says. So, okay, so we just flip it over. And I could probably show you, let's see if I can make that make any sense. If I were to do this in a different way, I don't know if I'll do it in a different way. So down here, negative 5x plus 6 less than 21. It's going to take me an extra step. If I add 5x to both sides, which is totally legitimate, all right? This becomes 6 less than or equal to 21 plus 5x. If I then subtract 21 from both sides, subtract 21, I get 5x is greater than or equal to negative 15. And now when I do the division, I get x on this side is greater than negative 3, which is what I have here. Okay, so when you multiply or divide by a negative number, I should have typed this out. Whenever you multiply or divide by a negative number, change the direction of the inequality sign. That's what we need to do. Okay, let's do one more of those, and I think we're done on this one, so it's not really that crazy a thing. Again, stop if you stop and pause and do it yourself if you want. Subtract now. Okay, negative 3x greater than or equal to 27. Divide by 3, negative 3 actually. Divide by negative 3, x, negative 9. Look, we divided by a negative number. We need to make this go in the other direction. And so there we are. So again, let's do the number line thing just to see what we're actually looking at. And so there's 0, there's negative 9. X is less than, so we're going in this direction. Boom, like so, and it's or equal to, so we fill in the circly thing as best we can. It's easier with a pen. Okay, so x is less than or equal to negative 9 is all or anything down here. If we're over here, it's not going to work. If we're down here, it's going to work. Plug in negative 10, there we have a perfectly beautiful answer. Okay, so there we are. That's all I know. That's all I need to know. That's about it for today, I think, right? If I turn this, it's a blank slide, so we're good. The only thing we need to remember differently from solving equations is that part about when you multiply or divide by a negative number, change the direction of the inequality sign. All right, thanks for watching. If you have questions, please ask. Hope you learned something, and we will see you, well, next time we see you, I guess. Thanks.